Good morning, everyone, and welcome to the 8th episode of our webinar series called Knowledge and Know-How with NetApp Support. If you've been to one of these before, this may be a review, but I wanted to first explain a little bit of why we are doing these webinars for our customers. Shiv, can you go to the next slide? So my name is Dwight Cranford. I'm a leader in the NetApp Support Center, and we've got 3 of our technical experts that are going to be presenting to you today. Shiv Pothan is one of our technical support engineers, and Scott Stanton and David Croson are 2 of our senior escalation engineers, and they're going to be talking about Astra Trident. Shiv, next slide. So just to give a little idea of why we do these webinars, generally in support, we only work with our customers when we're dealing with an issue or trying to resolve a problem. It's important for us to connect with you outside of working these cases. So we wanted to share some knowledge that we have, tools that we use, and make it easier for you to manage your environment. We also want to build effective partnerships, put our customers first, like I said, be proactive. And when you contact NetApp support, we want you to feel like you're contacting an extension of your own team. We also want to hopefully make it so that you are resolving issues more quickly or possibly avoiding issues altogether by reviewing some of this content. So during the webinar, we will have Q&A. You'll see a Q&A down at the bottom of your screen there. If you have any questions, please put them in there and we will make sure we get all those questions answered. Also, you will receive a copy of the slides that we're presenting today. And so just sit back, relax, and enjoy the content. Hopefully you're going to learn something great from us today. So Shiv, let's go ahead and get started.
Thanks, Dwight. Hi, everyone. Thanks so much for joining today. We'd like to officially start by introducing Astra Trident. NetApp Astra Trident is an open source dynamic storage provisioner for Kubernetes. It is the intermediate layer between a Kubernetes cluster and a NetApp storage platform. Astra Trident allows Kubernetes environments to easily provision volumes on the NetApp storage. This is especially helpful to a DevOps admin as it can mitigate the need to learn storage administration, as all commands can be issued from the Kubernetes environment. Astra Trident is currently available for on-prem and cloud deployments of ONTAP, as well as Element OS for SolidFire.
The first thing we need to know about Astra Trident is the backend that it uses. The backend for Astra Trident defines the relationship between Trident and the NetApp storage that you're going to be using it with. There are things in the backend like usernames, passwords on how to connect to NetApp storage, as well as some other options depending on what type of storage that you're using. The type of backends that are available, ONTAP NAS, ONTAP SAN, both of those also come in an economy model, which allows you to use fewer volumes. Also SolidFire, and then on the cloud side, we have backends for Amazon FSx, Azure NetApp Files, and Cloud Volume Services for GCP.
Next, we'd like to talk about storage classes. An easy way to think about storage classes is to think of them as you would a plane ticket. Plane tickets come in varying service levels, such as first class or economy. While on the flight, passengers are provided with different service levels, but the end goal of each ticket is to bring passengers to the same destination. The same concept applies to storage classes. Each storage class can be defined to provide different service levels, but the end goal remains the same, which is to provision a volume.
So some of the parameters that you see on the screen here show the different types of backend parameters that we can set. So if you have a storage class that you want to use SolidFire SAN and a particular number of IOPS, you can specify the backend type and the IOPS in the storage class so that when we provision storage, we use that backend and at least that number of IOPS. Some other parameters, if you get a selector set up, or if you've got parameters set up in your backend, you can use a selector to choose which parameters that you want to use. In this case, this one would be for a cloud model because it has geography equals east. and then performance equals gold. And so in the back end, you would have performance set up for different levels depending on what type of storage is available for it, and then also by geography. So those parameters will give us a little bit of a narrowing of what type of storage we use in our backend. So the next thing we're going to look at is persistent volume claims.
A persistent volume claim, or PVC, is a request for storage made by a user. When a PVC comes into existence, based on the storage class, it will reach out to Trident to provision the persistent volume on the NetApp storage. A PVC can request size and also access modes. The three common modes are read-write once, read-only many, and read-write many.
And in the example on the bottom of the screen, we can see the arrow pointing to the name of the persistent volume claim. In this case, the default is the namespace that this is in, and the name of the volume claim is persistent-volume-claim-NAS. That's quite a mouthful. So once we have a persistent volume claim, Trident will see that request for PVC, and it will go out to NetApp, and it will create physical storage. And then that will take the physical storage and bind a PV to the PVC. So looking at what a persistent volume is, persistent volume is a storage object that's been provisioned. It is provisioned using the information in the storage class and in the persistent volume claim. You can see in the example on the bottom of this screen that the PV name is PV hyphen, and I'm not going to read the rest of that out, but it is a UUID that's created by Kubernetes. So the PVs are volume plugins like regular volumes. The life cycle is independent of any individual pod that uses the PV. And so we'll look at that a little bit later as we go through this presentation.
Pods are also able to mount persistent volumes to store read-write operations performed by their respective applications. A reclaim policy is how the volume should be managed once they are no longer needed. Reclaim policies come in two main flavors, the default being delete. The delete policy will delete the PV when the PVC is deleted. This policy will delete the volume from the NetApp storage as well. Retain is a bit different in that it will allow the PV to remain on the storage and preserve the data within. Removing the PVC and the pod will not immediately remove the PV from the storage. To remove the PV, you'll either need to modify the reclaim policy to delete, or you can run the tridentctl delete volume command.
Right, so let's look at a hierarchy model of how this looks and how everything interacts with each other. So we have NetApp storage, and then we create a Trident backend that points to NetApp storage and tells us what NetApp storage we're going to use and how we're going to connect to it. Then we have a storage class that we create that points to which backend we're going to use and then gives us some parameters to know exactly which storage we're going to use through that backend. Then we create a PVC, and that PVC points to a storage class, which points to the backend, which points to storage, and also gives us some more definitions of how we're going to use that storage or how much storage we're going to grab. Trident takes that PVC, creates the storage. So we go back to storage again directly, and then creates the persistent volume in Kubernetes and hands the storage off to either a pod, or you can just create a PVC without creating a pod and just have the storage available to Kubernetes there. So now let's take a look at the YAML files that are required to create a storage class. So a backend is required here, but we're going to kind of ignore creation of a backend. We're going to do that for two reasons. First, the backend that you choose to use is probably going to be different, or could be different from what we would use. And we would use a very small model of what is available in the backend. There's many backends to choose from. The Astra Trident documentation, which can be found at docs.netapp.com, does an exceptionally good job at going over all of the details of creating the backend file and what you can put in it. But let's look at the storage class that we've got here. This is a simplistic version of storage class, but this is the valid YAML for it. First to note that the kind is storage class with capital S, capital C. It is case sensitive, so we do need to make sure that we've got the case correct. The name for this particular storage class is storage-class-NAS. The backend type is ONTAP NAS. That will match directly with the backend that we've already created. We've got a reclaim policy that Shiv told us about, and we've got that set to retain. And another option that we've put in here is allow volume expansion. This will tell us whether or not we can resize the volume in the future. And by resize, I mean make it bigger, because I don't believe we allow for making volumes smaller. There are some complications there. So let's take a look at persistent volume claims.
Once a backend and a storage class have been created, a persistent volume can be created through a PVC. PVCs are also defined through YAML files. We can see in this file some of the concepts we have previously gone over, such as access mode.
So here the YAML that we're looking at is a persistent volume claim. The name on this one is PVC NAS. We've got the access mode there. One of the things we haven't mentioned yet is the request for storage is 1 GB. This is where we put the size that we want our physical volume to be on our NetApp storage. And the storage class name points back to the storage class that we recently created of storage-class-NAS, as we showed on the previous slide. So now that we've gone over that, let's take a look at some of the methods that we can use for Trident installation.
Before attempting to install Astra Trident, API access must be configured for both ONTAP and SolidFire environments. In case difficulties are faced during this, please contact NetApp support directly for assistance. If you're deploying Trident for a cloud environment, the correct network routing from the NetApp storage to the Kubernetes cluster is required. IAM permissions are also needed.
The first installation method that we're going to look at is going to be Helm. We've got Helm as a package manager for Kubernetes. Helm uses Helm charts to show Helm how to install whatever package it is that you're installing on Kubernetes. Trident ships with a Helm chart that can be used for installing through Helm. As with most Helm charts, there is a values.yaml file that will allow you to change certain defaults for installation. So if you don't like the default namespace of Trident and would like to change it, you can change that in the values.yaml file.
The Astra Trident operator enables certain forms of automation. Regarding installation, an operator pod is deployed into the cluster. As we can see for the kget pods output here, the operator pod is listed on the bottom. This method implements easier modification, as changes can be made without having to uninstall and reinstall Trident, because it allows the usage of the kubectl edit command. Upgrades also become smoother for this reason.
And as I spoke about Helm before, this Astra Trident operator method is the method that will get installed when you use Helm. This is the method. So as we can see in the description below, and I believe we'll see this in the demo, you've got the Trident operator pod that is running at the bottom of that. And then the rest of the Trident pods that are required for running Trident. So the last installation method that we're going to look at is actually the first method that was ever used for Trident, and that's using Trident CTL. This is the most basic method. This will not give you an operator pod. So there are some niceties of having the operator around that you do not get with a Trident CTL install. So any changes that you want to make through Trident, or any upgrades that you want to do will require an uninstall and then a reinstall of Trident. An important note to know about is that whatever method you use to install Trident is going to be the same method you use for either upgrading or uninstalling. So if you've got an older installation of Trident that you use Trident CTL to install, and you would like to use the operator, you would have to uninstall Trident CTL and then install using the operator. If you're now using the operator and you want to switch to Helm, you would have to uninstall using the operator method and then install using Helm.
We'd like to go over a few logs we generally ask for when troubleshooting a Trident case. A support bundle includes all relevant troubleshooting logs. The command for this is Trident CTL logs -a-n Trident, -n being the namespace for which in this case is Trident. For operator logs, we'll usually run Trident CTL logs -l, Trident-operator, pipe gzip, and then redirect that into a file with the .gz extension. The logs can then be uploaded to upload.netapp.com/sg. Commands for troubleshooting will be a mix of Kubernetes kubectl and Astra Trident's Trident CTL commands. We won't be going over all of these today, but a quick tip is to append the -o wide parameter to certain commands to get more information. Okay, so now we'll take some questions before heading into the live demo.
And I'm not seeing any
And
questions that have come in.
Yeah, looks like we don't have any questions. So just a reminder, there's a Q&A button at the bottom of your Zoom screen. If you have questions, please put them in there and we'll make sure we get them answered.
This is Dave Crossan, and I work with Scott and Shiv on Trident. And today I'd like to show you a demo. Let me get this question. Okay. A quick demo of lab environment that we'll be using that is for Trident, and hopefully this will just help explain and understand some of the concepts that Shiv and Scott have already shown us in that excellent presentation. So I'll be running the scripts. This is a live demo environment, and I'll be just running some scripts to help type in the commands so that you don't so that I don't make any typos and just makes things go a little smoother. But as we go, each screenshot I will explain all the commands on it as we go. So as already stated, please post any questions you have in the chat, and we will try to answer them. Okay, so let's get started here. So Trident is created for DevOps environments that use Kubernetes to provide access and management for applications that need persistent storage space. Trident is installed and runs in pods on a working Kubernetes cluster, and that also requires a working connection to the NetApp storage. The Kubernetes API allows the communication of objects like pods within the cluster. And Trident is an app that runs on the Kubernetes cluster, which uses the Kubernetes API and listens for API REST calls from the Kubernetes objects. The commands kubectl or kubectl and Trident CTL also use the same Kubernetes API. Trident listens for Kubernetes API calls from the PVC requests and then sends a REST API call to the NetApp storage to perform the volume provisioning. Trident is configured using the Kubernetes CSI standard, which is the container storage interface, to provision volumes to NetApp storage. And Trident uses the Kubernetes CRD, which are custom resource definitions, which is just an extension of the Kubernetes API, to create the unique objects that it needs in the Kubernetes cluster that are specific for Trident to meet the requirements for the NetApp storage. So here we have, we're running, I'm showing the Trident call command. We're running the latest version, which is 22.07. There's another version coming out at the end of October. We release 4 releases a year. And so 07 was released in July of 22, and we'll have a new version here at the end of October, which will be 22.10. The cluster that we're running is just a simple cluster that has one master node and 2 worker nodes. And there are currently no PVCs or PVs created at this time. So as you can see. Okay, so the Trident main pod is created. So what we have here is 2 commands, Kubernetes get pod and Kubernetes get all. So we'll just go through the Kubernetes get all. So when you install Trident, it installs the Trident operator, which then deploys the deployment as well as the daemon set. So the deployment creates the Trident main pod, and that is where the Trident controller is and all the application for Trident. And there's 6 different containers running 6 different apps, like the Trident main, which is the controller that all the different pods need to be able to communicate with, as well as a container for auto support, for logs, for CSI provisioning, provisioning the volumes, attaching the CSI attacher, that attaches the pods to the nodes, CSI resizer, which allows for expansion of the volumes, and CSI snapshotter, which is for creating volume snapshots. So all those containers need to be up and running for Trident main pod to be working. And then there is, as you can see, each pod is created on a different node, or on the different nodes. The worker nodes, there's a worker node for each pod. As you can see, and that's the job of the daemon set to maintain all of the. There's one replica for each one pod for each on each node. So each worker node has one pod running on it. That's Trident, and each of those pods also have a talk to the Trident controller. So that kind of explains the Trident deployment. Okay, next I just want to show the little bit more about the storage class and the backend. So Shiv and Scott had a very good slide on the storage classes. In this environment, we have 2 storage classes set up, one for NAS, which will create volumes in the NFS volumes, and one for SAN, which will create LUNs on the NetApp storage using iSCSI. Both of these policies are set to the default of delete, to delete the volume using the CSI provisioner. And then the volume expansion has been enabled, so allow volume expansion so that as we consume space in our NetApp storage, we can increase the space as needed. Then there's a backend for each of these storage classes, one for NAS and one for SAN, and there's currently no volumes on either of those. So let me pop out to another screen real fast just to show you. When you install Trident, we're running version 2207. When you install 2207 or any version, it unbundles into a Trident installer directory. And then we've also provide a sample input directory that has all the different YAMLs, the example YAMLs that you can use for backends, PVCs, pods, storage classes. So I'm in the storage class directory right now, and just to show you, just again give you some more example. Storage classes are pretty much user defined and can be arbitrary based on your needs. So, one for in case you're using AWS to cloud volume service, or you can define bronze and silver and gold for different service levels, QoS levels, etc. There's a couple for NAS. This one includes NFS mount options that you might need when your users excuse me, are accessing their application. The one I've listed out here is the one that's for cloud, for if you have a topology where you only want to use the certain storage that's out there in a certain region or a certain zone of your cloud. This is an example. So that just gives you an example and place to go if you're in your in your Kubernetes cluster. So Trident doesn't have a fancy GUI because it's a middleware. It's the plugin that sits on the cluster that listens for API calls from your from the Kubernetes end users, and so we're looking at it from a command line here. Okay. The next, I just want to give an example of the backends. So we talked about storage classes, and there's 2 backends created for this, each mapping to a storage class. So this is the backend that's using the storage class for ONTAP NAS driver, and this one is and this will create NFS volumes, and then this is the backend that will create LUNs using iSCSI connections. And there's various different configs. These are fairly minimal configs, but for our lab, some of the main points that you'll need is you'll need an endpoint IP address, so the management LIF in this case, 135, and you'll need to be able to have that connection, working HTTP, and we'll be able to, connect to the storage on that LIF. And we're calling out the data LIF. That'll be where the mounts, when you assign the pod, it will mount using to the data volume using that IP address. There's also a feature, an auto export feature that you can use, which basically, as you add and delete nodes from your Kubernetes cluster, it will update the export policy on NetApp storage so that only the hosts inside the Kubernetes cluster are allowed access to this volume. This is the SVM that's going to be used on the storage, and then we have the credentials. In this case, these are in text, but as Scott mentioned, you can also use secrets. So we have an example of that. You can encrypt your credentials, and you can paste them directly into the backend JSON, or you can place them in a YAML file, a secret YAML file that will then create a secret object, and then you can just reference that secret object here. And I'll show you, let's see, on the NetApp storage itself. This is the current NetApp storage that we're using in this lab, and you can see that for the NFS management LIF, it's 135, and for the data LIF, it's 132. And for the iSCSI, it's 136. And if you don't call out the data LIF, it will find it and use that, and it will pick one and use that. And there's currently, again, no volumes for Trident right now. So then the next piece is, let's look at the pod and the PVC that we're going to create. So in this case, we are creating, we want to let's say, for an example, we want to use nginx. So that's our application. And so we're going to place that as in our pod. We're going to request, make a PVC request for a NAS volume. And that's up here. And we want that volume to have rewrite mini access with 1 GB of storage using the NAS storage driver. So that's what, and this would be the mount point that it's going to use. So now we've issued that command, and we've created a PVC and a pod. And the same thing for the SAN. Here's the SAN, pod, and PVC. So this will be actually using Alpine as the image, just to show that this is where your applications are contained, and then it's going to use the SAN driver. So up here in the PVC, we give it the SAN driver and the storage class for SAN, and we are requesting 1 GB. So now that we've created those, let's see if we're getting what we're expecting. So here's the PVC that's created, and we've asked for 1 gig, and it, when the PVC was requested, it went out to the storage and created a volume for each one of these. So we've created 2 volumes. One for the SAN is E06, as you see over here. And then the 8440 is the NAS, and each one is 1 gigabyte as we requested. And they are both, and we've also created pods to give the user access to those applications. And those pods are assigned to worker nodes. And the worker node is where the mount is actually happening. So we'll go out to the worker node here and check for the mounts. And we see that there is, in fact, a mount point for each one of those using the data lift for those PVCs. So as you can see, this is the NFS one, 8440. And then down here, we have the iSCSI device for the SAN volume, for the SAN one that was created. Next, I want to show you, just demonstrate, we talked about expanding the volumes or creating, as your application consumes more space, this is how you will, it's very simple to just request more space. So what we do is it's the PVC. The PVC is the request for to use a resource. So we update the PVC, and right now we've got 1 gigs. So we're just going to go in and edit the PVC, the persistent volume claim, and ask for more space. So we'll just go in and change the under resource requests. We just change that to, let's just say 3. And save that file. And as soon as that is completed, then the API call is sent. So we can see that the PVC request is, just because we just updated it, is 3 gig. And it's already come back, and the PV now registers 3 gig. And the PV is created and is bound to the PVC. Trident also has its own object to make sure that it's managing all the PVs that you create. And so it's also registering 3 gig, and we can check the storage real quick and see that on the storage, in fact, it is showing 3 gigs. So we were able to increase the space pretty quickly and easily. Okay, that's volume expansion. Okay, I think we talked about logging. So let's just talk about logging a little bit, because that's something that is something that support is near and dear to, is looking at helping you solve your problems by looking at logs. So when you first install Trident, each pod will have its own logging, and it comes with info level, which provides a good amount of information about the basics of creating and deleting your PVCs. But in case that's out of the box. But in case we need to, a little more information, we can enable debugging. So there's 2 ways of enabling debugging for the logs, which just increase the verbosity of the logs. One way is to increase it on the pods, all the pods themselves. So we do that by just patching the CRD Trident orchestrator with, which has a flag for debugging. We just enable that one command, and that will enable debugging on all the different pods, as you can see here. And when you do that, all these pods will be updated, and actually they get restarted. So while that's running right now, you may see one of those. I don't think it's completed yet. So yeah, 18 seconds. Yeah, this one hasn't restarted yet. There we go. So you can see that the pods are restarting just to enable the debugging. So while that's running here in the background, the other way to increase the debugging is to increase it towards the storage side. So to collect verbose debugging on the API calls that are sent to the storage, you enable this flag on your backend JSON. We looked at this earlier. This is for the ONTAP NAS backend. And you just enable this flag here. And then whenever you make an update to your backend JSON, you'll want to run an update on the backend, or you can bounce the main pod, and that will update the back end to resync everything, with the storage, and also enable the flags that you're wanting to enable. Okay, and then the last bit is so all that logging is available, but to make it simple, we also have created a command that will collect all the logs in one bundle, and that's just a Trident logs -a for all. And as you can see, it creates a log. It collects the logs for all of the containers, all support provisioning and attacher that we talked about earlier, as well as a log for all of the worker nodes and the registering of those worker nodes to the controller. So it collects all that into a one zip file that you can send to support, and then we can it helps us with the analysis. So that is the end of the demo, and so please let us know if there's questions. I think there may be some questions there, so let me stop sharing and maybe we can get to the questions.
Yeah, so there's been a few questions in the chat that we've answered. So I think Scott's answering another one right now. We did have a couple that came in through the comment section as well. And, one was about the recording of this webinar. Yes, we definitely record these and we'll send it out in the next couple of days. We also have a YouTube channel that I'm going to share in just a minute. So all of our webinars that we've done are posted there, and you can view those at any time. One of the other questions was regarding licensing. So Scott, were you going to address that one?
Yes, I will. So licensing costs for Astra Trident is both an easy and a complicated answer. The easy part is that Trident itself is open source and therefore free. So you can go to our GitHub page, github.com/netapp/Trident. There might be some capitalization in there, but you can search for it. And so you can download and run Trident. The complicated part of that is that you will have to have NetApp storage of some type, and that costs, and that varies. So I don't have a good answer for NetApp storage costs. But if you have NetApp storage, then you can use Trident for free.
Okay, thank you very much.
Another question just came in about using Trident on an ONTAP simulator or on a NetApp simulator. I have not tried using a NetApp simulator, but as long as the NetApp simulator will answer the API calls, which I believe they do, then you can use Trident on a NetApp simulator.
Okay, thank you. I think we have a couple more coming in. I don't know if we want to answer those, just read those out and answer them live. That may be quicker, and then we can type in an answer so that everyone sees it. So Scott or Dave, I don't know.
Yeah, one question is PVCs creating flex files on ONTAP and Metro clusters don't have much flex volumes. I'm not sure what you mean by Metro clusters don't have much flex volumes. I don't deal with Metro cluster a whole lot. Dave, do you know of any Trident installations on Metro cluster that you've encountered?
We do have. There are a lot of Metro clusters that are usually that we do. I don't have any. I don't know the answer to that one. So let me let's look up that one and respond back to you directly.
Okay, so we'll reach out to you via email after the webinar once we have an answer to that. I'm also going to provide an NG where we can, if you have follow-up questions, you can email us and ask us questions, and we'll get the answers. So we'll take that one offline and respond back. There's also one in the chat.
as a follow-up for another question that I answered in the QA, how do I get Astra Control Center or Cloud Manager? So Cloud Manager is in the cloud, so it is just cloud.netapp.com. Astra Control Center would be downloadable through the NetApp support site. So the best way to get that is to contact somebody in your sales team and work with them to get whatever licensing might be necessary for Astra Control Center.
Okay. And there's one also in the chat, not in the Q&A section. If the other benefits to using Trident other than ease of use to provision storage for DevOps engineer.
Well, provisioning storage is what Trident does. And I can't think of anything, Dave, but correct me if I'm missing something. Provisioning storage for a DevOps engineer to be able to not have to bug their storage admin for storage, and for the storage admin to be able to take snapshots of what the DevOps engineer is doing in case something bad happens, is a pretty good selling point in and of itself. Trident is used, I've mentioned Astra Control Center, so I'll throw it back out there. Trident is used in Astra Control Center. And to answer the other question that came in through the Q&A about Trident automating moving container workloads between sites and or to and from cloud, that would be something that Astra Control Center would do. And Astra Control Center uses Trident as part of its workhorse workflow. So yes, it's just provision storage, but we've got other products that use that to do even more with it.
All right. Thanks, Scott. And I think that answers everything that we have in the queue. So again, if you have questions, continue to put them in the Q&A so that way that everyone can see the questions and answers. But for now, we'll continue on, and I'll just have a few closing slides, and then we'll check for questions again, and that'll conclude the webinar. So Shiv, can you go to the next slide? Thank you. So again, I mentioned in the beginning, we do these webinars for you, our customers. So you're going to receive a feedback along with the slides and the recording of the webinar. Please respond to the survey. We want to know how we can improve. We want to know if we did things, what we did well, and again, what we can improve on. We also want to know what items you would like to see, what subjects you would like to see presented in these webinars. You know, we try to do these once a quarter. We haven't always been successful in that, but that is our goal. And the more content we have, the more we can get out there. So if there's something that you would like to see demonstrated or presented, please get that over to us, and we'll try to put those together for you. You can also email us. So I mentioned before, we do have an NG that you can email. So it's ng-supportwebinars@netapp.com. So if you have follow-up questions, or if you go back and watch video and something pops up, or again, content you'd like to see, please send us an email. And we also do have a webinar out there on NetApp KBTV. The link is provided here, and you will receive that as part of the slide package. So go out there and check out all the other videos that we have listed. And we do have NetApp Insight 2022 is coming up November 1st through the 3rd. It is all virtual again this year, so super easy to access. I have provided the registration link for you there, so go out and register. We're going to have some always on demand videos from the support perspective. We also have one of our sessions that you can register for and join. We've got them listed here. So again, when you get the presentation, you'll be able to see them and easily identify them, and hope you'll go out and check out our videos and attend our session. And that's really what we wanted to present to you today. I'll pause about a few seconds to see if we have any other questions come in. I think David is answering. Yeah, we've already answered that one. So about the how do I get Astra Control and Cloud Manager. Okay, so we'll conclude that. We'll give everyone a few minutes back to go grab some lunch or prepare for your next meeting. And again, please be on the lookout for invites to our next webinar. We post them on our support site, so a link to register there. Hopefully you also get an email. And please let us know what you'd like to hear. And we appreciate your time and thank you for attending and hope you have a great day. Thank you.